Hello everybody and welcome back to 3DF. My name is Zander and today we are going to talk about the hot end. Now the hot end is made up of two different components. There is the hot assembly and the cold assembly, which we will go over to our reporter in the field, Zander. Thank you, other Zander. Stay awesome. Thank you. As other Zander was saying, today we're going to talk about the hot end assembly. Now, the hot end assembly remains relatively the same whether you're using direct drive or whether you're using a bone extrusion system. And it's made up of two core systems. The hot assembly, the bottom half, and the cold assembly, the top half. But wait, we're gonna get way deeper into it. So let's get started talking about the hot assembly, and then we'll move into the cold assembly. So, the hot assembly starts off with a heater core block. Now these heater core blocks can come in all kinds of different shapes and sizes, but they all do the same thing. They are going to help transfer heat from the heater resistor right here, which is going to use electrical energy to heat itself up and transfer that energy through the heater block to your nozzle. Now, on top of the heater resistor, we also have a thermocouple right here. It's usually retained with just a little screw in the side. That's going to send information back to your controller, so that way it knows about what temperature the heater core block is at. So, moving forward from there, our next piece that we have is a nozzle. Now, nozzles come in all different shapes and sizes and are made of a wide variety of materials for different applications. We're going to get more into that on another day. So, we're going to put that nozzle right in the bottom here. And look at that. Now that we're done that, we have the entire hot end assembly. Now, we can start moving towards our cold end. Our cold end starts off with a heat break. The heat break's goal, as it sounds, is to break the heat. And it's typically made of more thermally resistant metals or even sometimes ceramics. And it's going to get connected directly into the top of your heater core block. Like so. Screw that right in there. Excellent. Now, we always want to keep a small space right here between your heatsink, and your heater core block. And the reason for this is to allow heat to directly bleed out in open air. Alright, so now that we have our heatsink on there as well, which is just a fancy-dancy contraption that allows cold air to pass through, drawing heat out of the assembly, preventing your filament from softening and melting way up here, when it should be in the heat envelope, as we discussed in our last episode, see up above. Now, there's a couple pieces that we're still missing in our cold assembly. The first is a pneumatic fitting. Now, we only find these in Bowden-type extrusion systems, and it will hold a Bowden tube that goes back to the cold end. In direct drive, typically what'll happen is your extruder motor will be right over top here, so that way you can push the filament through. Back to you, other Zander. Awesome explanation, other Zander. Thanks for that. You're welcome. That guy. All right, so now that we've talked about the hot assembly and the cold assembly, we're going to talk about the creep in the room. Heat creep, that is. Heat creep is residual heat from the heater core block that slowly pushes its way up through the heat break and into the heatsink. Now, ideally, in most systems, there'll be a cold fan that's pushing air past there, removing all that heat. But what if it isn't? What if it's not working properly? What if it is not drawing away enough heat, or you're generating way more heat than your fan can take care of? Well, what's going to happen is your filament is going to start softening up higher and higher and higher, moving up that heating zone, which we talked about in the last episode, into the heatsink itself. And that's going to lead to jamming, that's going to lead to under extrusion, and all around just kind of a bad time, am I right? So, the trick is to get your fan cooling enough that it's not going to cool so much as to require extra work from your heating block, while keeping your heating block hot enough that your filament's going to melt. So you want to be neither too hot nor too cold. Understand? Alright, so now that we've talked about the hot assembly, the cold assembly, and the heat creep, there's one more thing we wanted to talk about today, and that's about retaining heat. the more heat you need to generate, the more energy it's going to cost for you to operate your 3D printer. So what a lot of us will do is order specialized socks that slip over the bottom of the hot end and help keep that heat from getting out all these crazy sides. Now, in addition to just ordering something, you can also do casting and molding, and you know who I'm talking about, guys, who loves to do that. So, that is it. That's the end of the episode. Thank you for watching through to the end, and we'll see you next time. Don't forget, like, subscribe, and check out our episode on the heating zone. Good stuff. Excellent, excellent. That was a good episode. We'll just throw this back up here. Make a few adjustments. Okay, the devil's back. Oh, you're still here. Oh, you're probably waiting for the joke. Okay, so if you actually go back and watch the episode again, you will see some of our absolutely famous wall decorations here out in the other parts of the video. We'll actually pull them on and off and put them in displays, so I don't want to give it all away. There's a devil on the dinosaur. We make all this fun stuff mostly for our own amusement, so we want you to enjoy as well. Thank you, and have a good day. Like and subscribe.